Imagine you're running Netflix and you got billions of rows of data pouring in every single day. What people watched, where they watched, and when they stopped watching. You have to analyze all of that instantly. How can you even handle that humongous amount of data? The answer is Snowflake. Snowflake is basically a cloud data warehouse, not any traditional warehouse. This is fully managed, scalable, and runs completely on cloud. We don't install servers, we don't patch systems. We just log in, load data, run queries right away on the data. The best part, Snowflake is multi-cloud compatible, so it works across AWS, Azure, and Google Cloud Platform. And unlike old school databases, it's designed for structured and semi-structured data. So you can load files like CSV, JSON, Parquet, Avro, whatever you got. Now, the secret sauce that made Snowflake explode in popularity is this. It separates storage and compute. Let me explain. The data, your tables, your files, your schemas, all stored in cloud storage. And on the other hand, your compute, the power that actually runs your queries, is separate. If one team is running heavy queries and the other team is doing reports, they don't step on each other's toes. They work on their own separate virtual warehouses. They can scale it up or down whenever they want and only pay for the time when it's running. And that's what gives Snowflake insane scalability. You can literally go from single user to 100 users with no lag at all. Snowflake's architecture has three main layers, starting with the storage layer. This is where your data is stored. It is centralized, compressed, and managed by Snowflake. You don't worry about indexing or partitioning. Snowflake handles it all. Next up is compute layer. These are your virtual warehouses. Think of them as independent clusters that runs your queries. You can spin one up for ETL, another one for dashboard, and another one for machine learning, all on the same data. And lastly, cloud services layer. This is the brain. It manages authentication, query optimization, metadata, access control, and all the behind the scenes stuff to make Snowflake seamless. And that's the beauty of Snowflake's architecture. Complete separation, but total integration. So why is Snowflake such a big deal? Here's what sets it apart. Firstly, you don't need any infrastructure setup. You don't need to deal with servers, tuning, or vacuuming tables. Next, instant scalability. You need more power, just resize your warehouse in seconds. Next, concurrency with no conflict. Even 10 teams can query the same table with no locking issues. Everyone's reading, writing from the same storage, but their queries are running in separate warehouses. Next, data sharing. You can share data to another organization. You don't need any CSV exports, any APIs. Just instant sharing. Time travel. You can query from the data 90 days ago. And the last one, zero copy cloning. You need to duplicate a table or a database. You can just clone it right away. No extra storage required. And all these attributes combined make Snowflake ridiculously fast, reliable, and efficient. Now, you might ask, okay, this sounds great, but how do we actually ingest data into Snowflake? That is where stages and Snowpipe comes into the picture. A stage is like a waiting room. It stores your file temporarily until the data inside the file gets loaded into an actual Snowflake table. And here's how the flow goes. You create a stage, you load your file into the stage, and you create a table, and then you run copy into command, so you load the data that is in the file that is stored in the stage to an actual Snowflake table that you created. And here's where Snowflake takes it to the next level with the feature Snowpipe. So every time a new file gets uploaded into the stage, you don't need to load it into the table using copy into command every single time. You can just start up a new Snowpipe, and the Snowpipe automatically runs copy into command whenever the file gets uploaded into stage. Now, let's talk about the cost. We get billed separately for storage and compute. For storage, we get billed per terabyte per month, and for compute, it depends on how long the warehouse is running. We get billed per second. And on top of that, we can turn on some additional features to cut the cost, which includes auto suspend and auto resume, which basically turns off or shuts off a warehouse when it is idle and turns it back on when needed. Now, let's head to the demonstration. By the way, I just want to let you guys know, you can use Snowflake for free. Snowflake offers a 30-day free trial period for any new user, along with a $400 worth of free credit that you can use. in this 30-day free trial period. And you don't need to put in any payment information to access this free trial. So you can just sign up with an email ID and that's it. Okay, this is the Snowflake homepage. Now let's have a look at all the options that are available on the left pane. Starting with the projects. These where we manage all the projects and the workflows. These for the data ingestion, and these are the options available for data ingestion. These for data transformation. These for AI and ML operations. These to monitor the logs and historical actions. This is the marketplace. If you want to get a new data set, there are a lot of public data sets available here, which are free and few are to be requested by you to get access. This is a catalog where you can find all the databases, tables that you created. Data sharing for sharing the data to a second party. Governance, it's basically like access control and the security. Compute is where you manage your warehouses and the clusters for them. So let's create a warehouse and see the options available to create warehouse. So we have to click on new warehouse. We name the warehouse and we have to select the type and size of the cluster that we assign to the warehouse. And for the size, it varies from extra small all the way to 6x large. As the size of the cluster goes up, the price you get charged will also go up. So you have to be cautious selecting the right size for your cluster according to the load, or else you'll get charged extra for that. And advanced options includes, like we talked, it has auto resume and auto suspend. And we can also specify the minutes of inactivity before we trigger the auto suspend. We can also access multiple clusters for one single warehouse. We can specify minimum clusters and maximum clusters. Between this range, the number of clusters that are active depends on the load that we give it. Okay, that's how we create the cluster. Now see how we can ingest the data into Snowflake table. For that, we create an SQL worksheet. And I have a query written already. And for step 1, we have to create a database. Now, when you run the query, you can see the output right here and the execution time for that query right here. And also the query history for this SQL worksheet at the bottom here. Moving on to step 2, we create a stage where we store the file temporarily. That is created. And for step 3, we create a table with one column and the data type as variant. And by the way, variant data type belongs to Snowflake SQL. Snowflake has its own SQL, and variant is one of the data types. Variant can accept any sort of data. And here in our case, I'm going to insert JSON strings in it. And for step 4, we have to upload the file. To upload the file, we have to switch to ingestion tab and we have to choose load files into a stage because we created stage. Now we chose the database, schema, and the stage that we created. Now we browse the file that we're going to upload. And by the way, I got this file from Kaggle, from this dataset, which is Amazon reviews. If you want, I can leave the link in the description down below for this dataset. And yes, now we have to click on upload. And it takes a few seconds. For uploading, click on close. Go back to the worksheet, heading to step 5, loading the data from stage to table by using copy into command. This takes a few seconds, by the way, for the execution. There you go. Now here we can see the status as loaded. This says the data is loaded into the table, but to confirm it, we can just print a few records, or a couple records from the table. So let's do that. Now I printed 2 rows from the table just to make sure the data is actually loaded into the table. And here's the output. Now heading into step 6, which is passing the data. Passing the data in Snowflake is so easy. You can just use this syntax to pass the data and create a new table out of it. It is so easy to assign the data types for every single row. Just like that, I passed the data and I also created a table with that data.
And now in the catalog, under the database, under the schema, I can see the table that is created, which is parsed data. If I switch to data preview, I can see all the data that is in the table, and it is parsed. Now, this table is ready for any sort of task in the Snowflake. By the way, if you like this video, don't forget to subscribe the channel. And also, if you like the concept Snowflake, I'm going to do another project that is dedicated to Snowflake in this channel. So stay tuned. That being said, take care.